Hello and welcome, everyone. Thank you for joining us today for our virtual meetup titled Text Classification with H2O Driverless AI, a look under the hood. Today, we see a huge amount of data, text data in the forms of user reviews, emails, chat, text messages, news, tweets, etc. Access to this data, when combined with a state-of-the-art AI platform, can help organizations make smart business decisions and make life easier for the end users. In this session, we will go over how H2O Driverless AI can help us build and deploy state-of-the-art text classification models with ease. We will also cover the techniques used and also provide a live demo of the application of these techniques. My name is Saurabh Kumar, and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker for the day. Today, we have with us Jagadeesh Rajarajan. He's a data scientist at H2O.ai and is a part of the customer success team in the APJ region. He's an IIT Kanpur alumni and comes with a rich data science experience across multiple industries. Without further delay, I'd now like to hand it over to Jagadeesh.
Thank you, Saurabh, for the good introduction. As Saurabh mentioned, right, today we will be looking at text classification techniques and how do we approach the text classification problem inside driverless AI. So this would be our agenda, right? We'll start with an introduction of H2O and driverless AI, and then we'll see why we should learn text classification, some of the common use cases, and how an end-to-end ML workflow looks for a text classification pipeline. And then we'll go a deep dive on the text feature engineering techniques in general and how they are done in driverless AI. And finally, we'll follow up it with a demo and more use cases, right? So I'll start with an introduction to H2O, right? So we are an open source leader in AI and machine learning, right? We help businesses transform their business using AI. Roughly right now we have a team of 200 plus AI experts, right? Over 200,000 to over 20,000 companies use H2O in this open source things, and we have a very strong Meetup presence, right? And these are some of the facts which explains the same thing. Right. And in terms of what H2O offers to its customers and to the open source community, right? So we have our first generation AutoML platform, which is the H2O open source. We have our second generation, right, AI engine, which is H2O Driverless AI, which is what we'll be looking at today. And we also have our third generation tool, which is H2OQ. This takes the the fruits of AI not just to data scientists but also directly to the end users, right? So if you see an AA cycle, right? So at one end we have the business people, and the other hand we have the data scientists who are making intelligent applications based on the data which we get out of these business teams, right? And we deploy these models into the cloud, and then someone builds an application and then pass it on the value to the final end business users, right? So what we have today is a tool which does all of these things. And if you see in an architecture diagram, this is how it looks, right? So here we have our data scientists who are building data science models using H2O open source and driverless AI. And here are all the tools which we give them to make their process easier. And if you have large data science processes, let's say these are the some of the things. We have sparkling water, which is Spark plus H2O open source, right? And if you are a say a business user, right? So we have Q, right? Using Q, like you will be able to visualize the insights from this ML models easily. We have a smart model management solution, which is Model Ops. So this is again connected to H2O open source and Q. So whatever you build here can be maintained and monitored easily. And so we connect the overall things. For today's presentation, we'll be focusing on driverless AI, which is a key tool for enterprises to build state-of-the-art ML solutions. This is how it looks when we zoom into driverless AI, right? So we have a rich amount of data sources available which can be plugged in directly to driverless AI, as long as we have a tabular data in the form of some features and some output variable Y. Be it a text, image, or tabular data, driverless AI can automatically handle it. We give you automatic visualization. Automatically we select the best models among thousands of possible models and feature parameter space. And not just that, we also give you a low latency Python or Java scoring pipeline, which could typically in the order of milliseconds, right? So as soon as you upload the data and train a model, you have a like deployable production ready scoring pipeline ready. So one of the key advantages. And we also provide machine learning interpretability, right? You will be able to also inspect the predictions and see why the predictions are particular way. Right, and in addition to this, we also give you the option of adding in your own like custom code, right? You want a different feature transformation, or you want a different algorithm, or you want to optimize it on a different score. In addition to the huge like list of scorers and algorithms and feature engineering, which our Kaggle grandmasters have done already, that is also available, right? So these are some of the key strengths of driverless AI. To pick a few, right? The state-of-the-art model selection and cross-validation strategies. These are being battle tested by our Kaggle grandmasters, or hundreds of AI experts internally, and like a lot of open source data sets available, right? So there's some of the like key advantage you would get when you use driverless AI compared to doing this on your own. And also Mojo, right? For a lot of data scientists, the problem is how do we take the models which we have built into production, right? But when it comes to H2O or driverless AI, as soon as you build a model, right, you have a production ready Mojo, which we call just the model object optimized, which can be used for scoring any new data, like ready as soon as you build the models. And we also have a powerful genetic algorithm based feature selection and parameter selection tool, right? This intelligently selects the best features and the best algorithms based on like whatever iterations have happened past. And if you are running multiple experiments on the same data set, it also keeps a good memory of what all the features and parameters have been selected for the previous experiments, and make sure that you don't waste a lot of time in finding the obvious things. Right now with these things, right, let's go to why we should learn text classification in this session. Is one, there is an abundance of text data around us. If you see, especially in the business worlds, we have user reviews, emails, sales and support conversations going on, live chat messages, text messages, tweet news. So there is an abundance of text messages and text data available around in the form of unstructured data, right? And it's quite easy to build a model using this text data. It's not really so hard to have a very baseline. So this is a very simple example from scikit-learn, right? With few lines of code, we are able to achieve around 91% accuracy, right? And the third obviously is, because a lot of time we communicate in natural language, which is text, right? If you can understand and process these texts, we'll be able to create a lot of smart system using this text data. And that's why we want to look at text classification. Here we see, right, some of like use cases which can be built over text classification, which can directly give us business value. If you are in support, right, you can organize the support tickets into different buckets. You can even find similar tickets within the same bucket, right? You can find the customer sentiment based on emails, or we can automatically predict what would be the NPS given a customer email reply. You can detect languages, spam prediction. If you are in sales, you can probably do lead qualification, right? So on and so forth. There's a lot of things which we can use text classification, and truly these models have been like backend powering engine for a lot of smart systems which we see out there, like in e-commerce or sales or marketing. So this is how like an ML pipeline end-to-end looks like. So we have the data pipeline, and we'd have the model pipeline, and we have the model training and the model outcomes, right? So today we will spend a lot of our time in the model pipeline, and we'll also cover like what we offer for model training and model outcomes. So in terms of the dataset preparation, right? So this is how any ML algorithm works, right? So we have some data in the form of a tabular format. This could be like numerical, categorical, text, time series, or image. We transform this raw data set into a format in which these algorithms can consume, which is typically numerical, right? And then what driverless offers here is like over 200 plus transformers which are developed by Kaggle grandmasters and AI experts, right? So here we see some of this feature engineering techniques, right? So as soon as you upload a data set, so this data set is getting transformed into rich features, right? For text, it would be like say CNN embeddings, BERT embeddings, or TF-IDF embeddings, and so on and so forth. For image, it could be CNN, or like simple like transformations. And what we have for the model training is the state-of-the-art algorithms, right? We're starting from statistical models to tree-based models to advanced deep learning-based models. So these features and the models are combined together, right, in our like high-performance computing engine, and we create a powerful scoring pipeline. And once we have the scoring pipeline, we automatically generate you an experiment report, right? We give interpretability of these models, and along with the predictions, you also get this executable low latency like model scoring pipeline. Right, so this is how the overall pipeline looks. And for this session, right, we'll spend a lot of time in this gray zone, which is how we generate features for NLP, right, and how we choose the models and how it is finally getting served for the end customers. Yeah, so now we get on to driverless AI and how it approaches text problems. One of the key advantages here is, we have text columns, right? We create text-based features and we build a like ML algorithm. One thing which we get like when you use driverless AI is, in addition to this, right, you don't just have to be text columns. You can have text columns, numerical columns, categorical columns, and also image data available. So whatever features it is, driverless can automatically combine these things, augment the data, and build a modeling algorithm, right? So when we build a model on our own, sometimes we may just focus on text algorithm separately and tabular data separately, right? So when we have a tool like driverless AI, it takes the pain out of us, and it can augment different data sources and build one powerful model. So yeah, so these are the some of the feature engineering techniques popularly available. We also have in driverless AI, right? If you see any text feature, right? So the most important thing is how do we convert the raw text into a feature vector or output, which RxGBoost or a TensorFlow model can consume, right? In its basic format, so we would start with say TF-IDF and count vectorizer. And for beginners, let's give a decent understanding of what is count vectorizer. So this is a popular rhyme, right? Twinkle, twinkle, little star, how I wonder what you are, right? So what count vectorizer essentially does is for each of the rows, right? It takes the count of the time this word occurs. For example, here we see twinkle, the word occurs twice in the first row, and little and star occurs ones and ones, right? So this is all count vectorizer does. So like we have quickly converted a raw text file into tabular data, right, which like any ML model can consume. So be it support vector machine or naive Bayes or simple multi-layer perceptron. Now this can read this tabular data. So this is our X matrix, and using this we can easily do text classification. Now this method obviously has its flaws, and what is this? That if you see like stop words like a and like so these are going to occur a whole bunch of times, whereas a lot of important words in our data set might occur actually rare. So we don't want to miss out on the rare words and words which are important to the corpus in the at the cost of like words which are not so important for us, right? So we have something called TF-IDF. So using TF-IDF, we'll be able to like ignore some of the stop words and words which are occurring almost in all data sets or corpus. So we focus on words which are actually specific to the problem at hand. So if you apply the same TF-IDF on this thing, this is going to look something like that. So the actual value of TF-IDF per a particular word is directly proportional to the frequency, the term frequency in that corpus, and inversely proportional to the frequency of that word in all the corpus. So obviously all the stop words are going to have like much low term frequency, inverse document frequency. So we will be like focusing on only those words which are specific to the corpus. Again, this is very simple to generate in the form of code, right? So now with both TF-IDF and simple count vectorizer, right? So one obvious problem we have is we still look at words as individual entities. So there is no direct relation between say twinkle and star or any of these words, right? Whereas what word embeddings give us is that it creates a rich vector representation for each words, right? When we put a heat map, it looks something like that. And the most interesting part is when we project these words in a a multi-dimensional space, how it appears is quite interesting. So we see a lot of these analogies like this. So king is to queen is equal to man is to woman, walking is to walked is equal to swimming is to swam, and say Spain is to Madrid is equal to Italy is to Rome. And so to explain what this means, say you take a vector king, subtract the vector man and add the vector queen, you get subtract the vector man and add the vector woman, you get something which is not exactly queen but very close to queen. So we have the king, we have the man, we have the woman, and this is the computation looks like. If you zoom in and see, the vector queen is not exactly the same as this, but it's very close, right? And this is what we see here. So this is a king vector, right? When you subtract the man vector out of here and then add the vector women which goes from here to here, so we will approximately reach queen. So we have reached somewhere around here, and we look at all the word vectors in the corpus which are similar to this transformation, right? Oh, we get queen, right? So now what we have essentially done by using word vectors is we have captured the context of different words, and now suddenly the words are not individual entities anymore with some numerical value, right? Each of these words has a rich representation of the context it provides. So king has a context. It is used at a whole bunch of different like areas. Man has a different context and woman has a different context, right? So obviously when you use word vectors, we get slightly like better results compared to simply using TF-IDF or count vectorizer in most scenarios, right? And if you want to go slightly one level like deeper than word vectors, we can use some of the deep learning models which are RNNs, what I'm presenting here. So here we have long short-term memory and gated recurrent units. Now what they do slightly on top of simple word vectors is, right, so they can create long-term dependency context, right? So using, so this has the input gate, forget gate, and output gate. Using these gates and the memory cell it has, it stores long-term dependencies, and it can predict an output even like with words. Let's say you have a sequence of words like twinkle twinkle little star, and if I want to predict what are the next four words, right, how I wonder what you want, right, it can keep track of such like long dependencies of what all the words which have happened so far and predict the next set of words. Or say in a business context, you have a like a rich customer review, right, and you want to process the entire customer review and want to predict, models like LSTM or gated recurrent unit would be quite handy, right? So that with so this is what we have covered so far. So we have covered TF-IDF, count vectorizers. We've covered word embeddings, and the same technique of generating word embeddings can be also applied to generate character embedding, right? And once we generate these features, right, we pass it on to a bunch of different models inside driverless AI to get the like final prediction. So in the case of say TF-IDF or count vectorizer, we can directly pass it on to a truncated SVD for reducing the dimensions. We can then apply a linear logistic regression, or we can pass it on to our other models like XGBoost, LightGBM. All the models are available for evaluation, right? For word embedding, once we have this embeddings, right, so we either pass it on to a CNN model or a like bidirectional GRU RNN model. So driverless AI will take care of these things for you. You just need to specify whether you want to consider these models in the feature evaluation space or not. And what we have latest with 1.9 or recent edition is what is always like BERT embedding, bidirectional encoder representation from transformers, right? And so we have, thanks to our Kaggle grandmasters, we have the following BERT models and BERT embeddings available, right? And so BERT is currently the state of the art in terms of text models, right? And we'll be demoing how BERT gives some of the best results in the open source datasets which we have, and how you can quickly generate a BERT model. Some of the advantages with BERT we have is it's pre-trained on large corpuses, right? And because it's pre-trained, right, it can like if you want to fine tune it to any different task, you'll be able to do it quite quickly, right? And it captures the word context bidirectionally, and also it's much faster to train compared to LSTM, right? And most importantly, it does give state-of-the-art results on a number of NLP tasks. So right, so with these things, it's quite easy to train a model. Now let's have a quick demo of driverless AI, of how we can approach the same things using this thing. So here we have a data set, which is the airline sentiment data set, right? So if you go to quick and view details, this is how the data set looks like. And as I mentioned, right, so this one has text columns and a bunch of other columns as well. So let's look at the data in the raw formats, right? So we have like sentiment. So we have the name of the airlines, and we have the actual text, and we have the user time zone and tweet location. Now, if you want to predict a model based on this, all you need to do is click and select predict, right? So you give thing like NLP baseline 1, right? And so this is the data set. I want to train. My target column is airline sentiment, and I'm going to drop the columns which I don't want and select only those columns which I want to consider. So in this case, I want the airline names and I want the text, obviously, which is the most important. I would rather look at tweet location and user time zone. So once I select these things and say done, right? So we will be able to see in the left-hand side for one is driverless AI automatically pre-selects a certain level of accuracy, time, and interpretability settings and a scorer for this specific data set. And then it says in the left-hand panel, like what models which driverless AI is trying to consider for this evaluation. And as far as the feature interpretability is concerned, what all it is considering and what would be the future things. Now, if you increase or decrease the accuracy or time setting, it's going to affect the kind of models we choose and the number of times the feature evolution pipeline is going to run. So in general, when you increase the accuracy, right, so we're going to do like more powerful cross-validation strategy, and it's going to take like more time. Similarly, when you increase the time, it's going to like run for like much longer time. It will consider like more features. And if you increase interpretability, right, it's going to make the model slightly more simple and make it faster. So if you want a powerful ensemble, maybe you can increase the accuracy and time and keep the interpretability to a low value. Or if you want a model which is more simple, not really like so complex, right, you can increase the interpretability and decrease the accuracy and time settings. And to see like some of the techniques which we have discussed so far, like how do we enable this in NL like driverless AI. So by default the TF-IDF and confactorizer SVD things are applied. If you want to specifically use CNN or bidirectional GRU or CNN based models, you should just like turn this on, and this will enable the models to consider these models in the form of this thing. And if you want to train say a BERT or any of this like models, so enable the PyTorch models on. In addition to this, we also have an option in the models in the experiment section where you can directly choose either NLP model or NLP transformers. Now what this does is this disables like all the other settings and brings in a specialized set of models which are chosen by our Kaggle grandmasters. Right now, this is gonna do so let me just look at in the left hand slide. So it will disable all the other models and bring in specifically this Kaggle grandmaster recipes, right? So if you want like state of the art model quickly built and just fine tune it for your specific data set, you will be able to give these things. So with this thing like you'll be able to train for now, right? Just for demo purposes, I would keep it into auto and go to the NLP setting and switch on all the models which we typically have. And you can either launch an experiment or we have this feature called create leaderboard, which is quite powerful. So what I'm going to do is it's going to create, so if you're a data scientist, you will be running a bunch of experiments to see, right, how different models are performing, right? So this create leaderboard option automatically does that for you. So here, so we have quickly created a project, and in this project you see, right, so driverless AI is going to run a whole bunch of models for you to, in this it will see, right, which models are performing. So instead of you manually like doing this one by one, driverless does all this for you. And for all these experiments, you're going to get an auto documentation like machine learning interpretability. You can visualize the feature pipelines. So I will show you with one of the experiments which we have already run. So there's something which I ran a couple of days back, right? So let's say single decision tree. Yeah, let me just select this thing, right? So this is one of the models which ran in the previous iteration. Right now, if I want to quickly see how this model is being done, so this is what it is. It takes the name text, and if I want to click in the zoom, like you'll be able to also see the visualize the individual decision tree as well, right? So this is quite powerful. It definitely helps me to understand some of my models. If you want a quick like summary of the report, you'll be able to download this report that for every model, right? So we give you an auto doc on like how the model has been trained, what are the feature engineering transformations have been applied, and what the accuracy setting looks like. We yeah. So you'll be also able to interpret all these models. For example, if I go on some of the already other, so for some of the models, so this is a simple TF-IDF plus SVD based model, and this is the BERT model, right? So if I want to go on this thing, right, so you'll be able to get some quick insights on how different features are combining together. For example, so if I see here, right, so I had the text column and I had the airline. So because we have like columns apart from text as well, so we see that these four columns are turning out to be like more important for this specific experiment, right? And another advantage which we want to put it up is so as soon as we train these models, let me go to any of the completed model. Yeah. So as soon as a model has been trained, we already have like production ready like scoring pipeline. So now we have like Mojo scoring pipeline, which is available for using Java, Python, or R, right? And we also have a like basic Python scoring pipeline. So if you just have a pure Python based setup, right? So as soon as you build a model, if you just if you're happy with the accuracy settings and you want to quickly like go over this, you should be like able to do it without any problem. And we also have an option of deploying it to cloud, right? So this is our genetic algorithm based feature selection, right? So as we see that it is so this is a BERT based model. So it have obviously selected burst, and to give you a comparison of how some of the recent things. So we have a like airline sentiment data set. So we have like a CNN or GRU based model, and we have BERT. We see that the BERT model obviously outperforms the CNN and TF-IDF model by a like big margin, right? And also if you just want a pure this is the NLP pipeline. Let me just compare these three things for you to give you a quick idea. So if you see, so here I have like a BERT only model which can be trained like, so here I have a BERT transformer. Here I have a CNN plus by GRU model, and here is the full BERT model. So if you see that the BERT model is giving a log loss of 0.41, the BERT transformer is giving a log loss of 0.44, and the CNN plus by GRU giving a log loss of 0.46. The interesting thing is, so this one took significantly less time to train compared to this, so which we can see from here, right? So the NLP pipeline, so this one just took 26 minutes because it was a pre-trained model and all we did was final tuning. So this one gave a better results in the test set, and also it's significantly like faster to train compared to like a TF-IDF model or a CNN plus by GRU model. Yeah, so with this like we have covered this thing, and these are some of the experiments which we have just triggered. So all these things are going to run, and if you want to see individually, like this is the in the project section, if you go right, you will be able to see how these models are getting run. And if you have a GPU, right, all of these models wherever possible, it takes advantage of GPU and like makes it easier for you to like build multiple models in parallel. Yeah, sure. So with this, we have covered like how to like look at some of these techniques in driverless. So we looked at TF-IDF based models. We looked at the word embeddings and character embeddings, and we also looked at how do we enable different MERT models. So one thing which I want to add on top of this is, if you want anything more than this, right? So we have something called driverless AI recipes, right? So if you, this is an open source library, right, you will be able to see like the different like text, different transformers we have specifically for NLP, right? So we have this thing, and you will be able to select any of these things. And we have the following. So we have data recipes for text pre-processing, to creating meta features out of any text things, right? If you want, so let's say you want to create features based on text readability, how readable this text is, and if it would be useful for you as thing. So we have recipes for that, and to detect languages, parts of speech, summarization, topic modeling, and spelling correction, right? So these things should give you a good idea of like what are things which you can do. So anything which you think is not really available, so we'll be able to import these data recipes and quickly get it. And importing this recipes is also a very easy task in driverless AI. So all you need to do is, let's say if I'm going to any of the experiments, right, and I want to use a specific, let me select one completed experiment. Yeah, so let's say I want to add a custom recipe to improve this specific experiment, right? I am creating a select new model using the same parameters. So all the parameters of the previous experiment will be the same thing. Just saves our time to not repeat the same instructions which we have given to the machine, right? And inside the recipe section, we have something called load recipes from URL, and we have the section called official recipes, right? I'm going to click both, right? So this is going to give this recipe URL, and I've just clicked the official recipe URL. Inside this, I'm going to the transformers, right, in NLP, and select any of the recipes which I want. Let's say I want text language detect or text readability transformers, right? So you click the raw image, the raw file, select the URL, and just copy paste this, right? So if you click save, but I'm not going to save because I already have some of these things, right? So just click save button, and that recipe is automatically available, right? So it's as easy as this. And we have like, thanks to again our Kaggle grandmasters, we have built a whole bunch of these like transformers, text feature transformers available, not just for NLP, like also for other like kind of series, for time series, for signal processing, and for everything, right? So we have a bunch of like transformers available. All you need is copy paste this code, and copy paste the URL, and pass it on to driverless AI. So with this, I believe like we have covered a good amount of techniques, and you'll be able to quickly upload any data set, right, and like trigger a model and see the results. And so last step, let's just see some of the models which we had triggered. Let's see if some of them have been completed or not. Yeah, so as far as the Ireland sentiment is concerned, right, some of the models are almost gonna complete, right? This is first at the to start with, right? It is creating a small sample of features, and it is creating a quick decision tree. Here we see the TF-IDF models are being selected because just to get a quick understanding of the data set, and also to create a quick baseline. This serves as a good thing, and later on in the pipeline, it will also create like powerful models, say like, so the TensorFlow models come like slightly like lower in the queue, right? And we'll be able to get like a lot more insights through this. Yeah, sure. And if you want to learn more, like we have our H2O.ai learning center, right? So you have like a lot more tutorials and like content constantly being uploaded on this, and we have a lot of like upcoming meetups. Please stay tuned to our meetup page and our H2O.ai learning center.
I think with that, we are at the end of your presentation, Jagdish. Should we open up for questions?
Yes, sir. Yeah.
Great. Number one, how to handle if the number of class labels are high?
So is there any instruction on how high it is, like the number of class labels? Like, is it like in the order of
We can get
thousands or in
back
the order of,
if you don't want to answer the question right now.
okay. Like let's say, let's answer this. Like, so let's say if we have a like a large number of classes, One approach usually is to decrease the number of like it's break it down into like multiple hierarchies. So that's one option. But H2O can as such handle like large. Say you have like 100 labels, H2O should be able to handle it. So the driverless AI, as long as the data can be held in memory and the matrix size is not a problem, our engine can handle it. But as a general rule of thumb, let's take Amazon's product classification. Right, I've worked on a similar problem before. Now this one has some 1 lakh labels. If you want to categorize all the product into different brands, right? So what we typically do here is to group the data into different buckets. Say like we'll build one model for electronics, one for say mobile. So it comes up in a hierarchy. Right? There's a electronics bucket which contains the mobiles bucket, and the electronics is still a part of the larger bucket. So hierarchical modeling is one thing. If you can logically group them into subclusters, so this would be like easier things. But as far as driverless AI is concerned, as long as it doesn't explode to the order of say 50,000 classes, right? So that is one thing I have faced. It just makes it impossible to train a model with 50,000 labels in one model. Apart from that, driverless should be able to handle like up to say 500 or 1,000 labels. Should not be a problem at all. We support up to 10,000 labels, like theoretically, but I would practically recommend like say 100 labels like in any ML model, right? So we should not think more than 100 labels.
Great. Thank you, Jagdish. Next one, how to deploy models like BERT in production? Do we need GPUs?
Yes, so if you have GPUs, it will be like advantageous, like because it takes like if you want to run train these models, right? So having GPU, it's much faster. So the demo which I had shown is the models are trained in GPUs, right? And as far as like deploy, like how do we deploy is it concerned? You don't have to worry about it. So the mojos are already self-contained. So you just need to like run 3 lines of command to deploy the mojos.
Wonderful. In production, is it advisable to train a model per customer or use global model for everyone?
Okay. So it's from a like privacy and data security point of view, like it's be good to like train one model per customer, but we can take advantage of some of this pre-training. For example, if you look at how BERT works, that it's already pre-trained on a like large corpus, right? So if you have a say if you're working in patent data set or say CRM data or any of this data, if you can pre-train on a like larger corpus for a general task, it's going to give better results for those specific tasks. And however, for building models, it would be good to build at a like per customer level, so that model will be more accurate.
Thank you. In the fleet industry, I want to detect fuel fraud based on fuel transactions. Do you think it is possible?
Yeah, sure, we should be able to do the thing. So when I say like fuel frauds based on fuel transactions, so these are sequence, right? So A happened, B happened. So this is much similar to text
Yeah.
data. So like text is a sequence, and this is also a sequence. Like technically, let's say, right, you just transform all the event to a particular value, like a particular text, right? Should be able to, like, obviously there can be better models, but almost all the models which we discuss, say like BERT or LSTM or GRU, so these are sequential models, right? So this look at the data. So we have bidirectional GRU and like BERT, which is bidirectional encoder representation from transformers. Both should be able to look at the patterns in the sequence and detect any interesting patterns of anomaly or fraud.
Thank you. Language detection could be done through text qualification. I'm assuming that comes with a question mark. Is it possible to detect language directly from the speech sample?
Speech sample. So like a lot of people, what they do is like they convert the speech to text, right? And then detect languages. So that way it becomes much easier than we build like audio. So there are two ways we look at this. One is we can directly so transform. So we have data recipes. Let's say we transform the audio files directly into a feature representation and pass it on to driverless AI. That is option one. Option two is to simply convert the like audio. There are a lot of APIs available to convert voice to text, right? So we just convert it to like text just based on what it pronounces and pass it on to like a model. So that should be much faster.
Thank you, Jagdish. Any plans to integrate with OpenAI GPT-3 frameworks for faster validations? Would you like to take that question?
Yeah, I'm not an expert on this thing, so maybe like someone like some of our Kaggle
Sure.
grandmasters would be able to better answer this question.
Absolutely. Uh, there's a question on the kind of platform we are. I'd let you take it. Is the H2.ai platform a SaaS platform, or does it run on your local machine? Because you mentioned if you have GPUs, so if you could just clarify on the the kind of platform, the environment, et cetera, for our attendees, that'll be helpful.
Sure. So like it's not like we control it. So if you want it on your cloud, we can install it on your cloud. If you want it on your on-prem, it is possible, right? If you want it on Docker, Microsoft, AWS servers, like we support a wide range of deployment options. We can say it is SaaS, but if you also want it as an on-prem thing, like I believe we support on-prem as well.
Great. What approach should we use to categorize the large text? Couple of paragraphs.
Okay. What approach?
Mm-hmm.
I'm just asking, what approach should we use to categorize a large text? Is that the question?
To categorize a large text, which is a couple of paragraphs. So they have a couple of paragraphs which they want to categorize. How should they go about
Uh,
it?
Yeah, quick answer would be BERT, like if they're using driverless AI, right? And if they are just like trying out on their own, something like LSTM should be able to do. But in the like if it's like large paragraphs, we've recently seen that BERTs definitely outperform that compared to LSTMs.
Wonderful. Thank you, Jagdish. How do I make use of LRU/disk-based cache systems in production? Would you like to take that?
No, again, I'm not really an expert in like LRU based caching systems or any of these things. So like I'll because it's not really connected to NLP, so we'll park it.
Absolutely. Next question. Is there a Slack community associated with H2.ai Learning Center? Yes, we do. If you go to community.h2.ai, that's where you'll find all the resources that you need, and that we also have a Slack channel there. You can also go to training.h2.ai and then find all the resources there as well. Next question. Besides generic sentiment analysis, positive, neutral, negative, does H2O have more fine-grained sentiment or emotion analysis?
So the thing is that like are we doing so this can be done in the context of what we have as Q, that if someone wants a specific fine-grained thing, right? So just to give a quick context for the general audience, what Q is. So Q is could be think of as a layer on top of driverless AI where we build things specific to different industries or different verticals or even like horizontal places like say marketing or sales. We build certain applications. So this can be done in the context of Q. But if you see driverless AI as such, it's in its base, it's a supervised learning platform, right? It's an AutoML solution, right? So given a feature vectors and a set of labels, right? So if you already have a like data set with pre-embedding, let's say you have customer support, right? You mark the incoming tickets into different categories, like it could be 15, 20 or 30 categories. If you have it labeled, like driverless will just quickly do it for you, right? That shouldn't be a problem. But if you want a model out of the box, you just given an unstructured text, right? Just a set of like series of emails, and you want us to like do this thing. So this can be taken in the context of Q, but not in driverless AI.
Thank you. What kind of office presence does H2.ai have in Australia? Well, we have our team set up in Melbourne. We also partner with MIP Australia for regional reach across ANC. Please feel free to reach out to any one of us and we'll be happy to connect. Next question. How do I go through this or past webinar later? This webinar will be sent out in an email shortly. All of our past webinars are up on our YouTube channel, H2O AI. Next question. Which model performs well in text summarization of companies' large public financial filings, earning reports? Is there any language model required or just text processing would serve the purpose? Would you like to take that, Jagdish?
Yeah, so BERT should be able to do. And one thing which I want to add on this thing is that we have also like industries, like because this can be like trained for specific corpuses, we have something called FinBERT. Like it's possible to train. So this is a work in progress. Like we already have something for finance. So if you want to summarize a financial document, so maybe what we have is FinBERT, right, which is a BERT model customized for the financial industry, right? Would be like able to do this. Again, this is just a like representation. On top of this, the summarization becomes easier when you have this thing. So BERT models initially came from this transformer architecture, which can do sequence to sequence modeling. Say like you want to transform from English to French or French to English, it's possible. This text summarization is a similar problem where you have a like a raw text, you want a summary out of it, right? So like BERT should be able to do it. A better option than BERT is BERT fine-tuned for your specific industry. For finance, I know that like we have one which is FinBERT.
Thank you, Jagdish. Next question, can you give us a few tips for faster inference and use of caching systems?
Faster inference. So our okay, brain cache, like this I would keep it to specific to driverless AI because there's a lot of ways of doing this. So what we do is something called brain cache. Let's say right now, for example, right, I was just running whole bunch of experiments on the same data set, right? And when we have like a lot of people doing the same thing, it doesn't make sense to think everything from the scratch if you know something which is obvious, right? So what brain cache at our end does is that if it knows certain models or certain features are very important which have been successful in the previous iteration, it is pre-selected in the genetic algorithm phase, so it doesn't spend a lot of time in searching for those obvious winners. And then using that, it creates more variants and then do it in this way. Caching is definitely useful for machine learning, though a lot of people don't use it. So if I just plainly use Sekiras or scikit-learn, right? I, as a data scientist, might not think a lot about caching because a lot of engineering work involved in doing that thing. But like practically, once I started using driverless, I see like a lot of value in caching because the experiments just run much faster. So one is caching. Number
Thank
two
you.
is we can also suggest them early stopping. So you can enable this in driverless AI if you want. Like if you want the experiments to run even more faster, you just specify a criteria, right? Beyond this criteria, I don't want to further optimize my models. So that can again speed up in the context of caching.
Thank you, Jagdish. Next question, how to make a smart chatbot without any framework packages like Rasa? What are the steps, algorithms that can be useful here?
Oh,
Do you want to
nice.
take that question?
Yeah, so I've built like text this is similar thing before. So the key thing is here is you build different context. Like again, we have to take any specific thing. For our case, let's say we'll take the marketing or like lead sales pipeline, right? A person comes in and you want to automatically put it. You design different context. Let's say uh, just to give a very basic workflow, a person comes and visits your website, right? You want to put them into what they are interested in. Are they your existing customers or this thing, like a set of this thing? So you specify different context and probably build simple models for each of this context, right? So basically each of the if you look at in terms of network, right, every context becomes a node, right? And based on the classifier or the like decision, right, you pass the person from one node to another node. So you simply create a network in paper and build different models, right? The easier it is, the better. And so for different things, there can be, let's say, if you think that if a person is just looking for a solution, support ticket, or a say resolution, and if you have a support document already prepared for it, right, if the classifier triggers to be yes, just give the text classification. But if none of your existing classifiers can detect the problem, right, you pass it on to a human, which is the live support ticket, right? So maybe a person can come and handle it. And as the system gets evolves, right, your goal is to keep on increasing the deflection. So as much as possible, if the like model is able to detect the context and give the solution to the customer on its own, your classifier is doing a great job. And the metric to monitor here is the deflection rate. How often customers end up reaching out to us or getting dissatisfied and leaving the pipeline. So we need to decrease that number by having intelligent nodes. Each node can be think of a text classification problem and some rules on top of it. So this doesn't need Rasa or anything. You can just create some 5-6 simple models and like connect them through APIs and get started with this.
Wonderful. I'm sure that was very helpful, Jagdish. Next question, how to handle if the dataset has 100 plus class labels? what would be the best approach to train models in this setting?
So one thing could be like, if let's say like let's take a like much larger thing, let's say 1,000 labels or 10,000 labels. So one thing is that we don't want to create a huge feature corpus. Let's say you go with the TF-IDF based thing, right? And if you have a huge corpus, like now imagine I have 50,000 columns and like so many, like say 1,000 labels and a million rows, right? So the matrix is going to explode, right? So we need a much larger machine to run it. Like one thing could be to, if possible, if we can like reduce the feature dimensions, that will really be of help, right? So that is one approach. Number two could be to obviously break it out into hierarchies. If there are obvious hierarchies, it is good to like go by those hierarchies. The third one could be to use only TensorFlow models, because TensorFlow models can run in epochs. So all it does is save the matrix and so on. So inside driverless AI, you disable all models apart from TensorFlow models and just try to go on it. I mean, if you truly can't decrease the feature dimensions or the labels in any way, run a TensorFlow model, and we give you the option of like taking control of the epochs, like how many epochs you want, what is the batch size you want to run. You fine tune the batch size, you keep a small batch size. It might take slightly more time to run, but it will definitely not through memory error.
Great. Thank you, Jagdish. Next question. You mentioned a lot of great approaches on how to approach, how to go about text classification. Can these approaches be used for embedded systems?
Um, so uh, okay, I am it's an assumption based answer. Like I'm assuming that when they say embedded systems, right? So they wanted like IoT platforms or something, which they wanted to be faster, right? So again, not really great, because there is something called TensorFlow Lite, which I'm aware of, which can be used to do this fast. But like if you look at an auto ML solution as such, right? So we build a powerful model with ML interpretability and those things. So what could be useful is you build a baseline model. If you see in the leaderboard, right? We create a powerful model, and we also build a simple model. So we might have to build something simple that we can maybe get the insights out of our, like, the grand auto ML experimentation process. We can understand what is happening, which features are more important. But like to run specifically in embedded systems, I'm not sure whether as such we can support it. But if their concern is say network latency fast, because most of this IoTs when they are deployed, right, there is typically like the network is not so great, like it can't just go on and off, right? So now if you're going to have a powerful model which needs a like a good internet connection and processing speed, right, some of these things won't be available in this embedded systems. So in that way, I think like if they build a powerful ensemble, that might not help them the purpose.
Great. With that, we have one more question come in. Okay, so he clarified approaches to identify context and hence reduce deflections to support. Would you like to revisit, or should we take it offline?
So approaches to determine context, right? So I think so their thing is that, let's say if they don't have any labels, because with labels we have already answered. If you don't have any labels, so we have some custom recipes which we've shown, right, which our Kaggle grandmasters have created. So these are like LDA and like k-means based like clusters. So you can cluster the data into, say, like you use something like a BERT transformer, right, and create feature embeddings and group them into different clusters. And once you have them, those clusters, then maybe it'll be easy to like label them. For example, let's say just support, in the context of support, right? If you take your support data and pass it on to BERT transformer and run a like topic modeling or a clustering algorithm on top of it, you should be able to see that a different pattern. So one thing could be bugs, one thing could be questions related to a specific topic. Let's say like for driverless, we have a machine learning MLA is a topic. For us, like mojos are a topic. For us, data science or time series is a topic, right? So we will see such obvious clusters when we run the same on our data, like that. When customers run on their specific data, depending on their industry, right, they will be able to see some different clusters, and those can be used as a baseline topics until they actually start labeling their own data.
Thank you. Next question. What are the steps to follow if supposedly I wanted to classify crime types out of first information report or FIRs? Then they mention the types of crime that people commit. Is there some predefined model that could be used for classification?
So this would fall pretty much like the BERT, which is trained on Wikipedia. Like, so all this crime thing could be trained as this thing, right? You can take a BERT model and like run it on, try to get the results. Or if you have like if you want like a pre-training on the like crime data, let's say if you have a huge corpus of FARs, some sort of public database available, right? If it's India, let's if you can get like all the Indian FARs in some public portal, if you can like run it through that thing, right, and then get the predictions, we'll be able. So I have seen a similar approach done for patent data. Like you have a lot of this patent models which have a specific language and lingo, right? And you want to classify the patent data into different groups, right? So a lot of publicly available patent data is available. So you pre-train on the patent data, and then you use it for different classification. Classification as such should be quite simple.
Thank you, Jagdeesh. Next question, how do you do NER with DAI? I'm not sure if you need more context, but do you want to take that?
So I should check on our custom recipes. I'm not exactly sure. We have a lot of custom recipes, but this specific transformers, I would suggest to check out our driverless AI recipes, which is open source and publicly available. So we should be able to say NER just like one technique which can be run inside this thing. So you can run it as a supervised model. And we also support some of these things based on publicly available libraries, right? So we should be able to check it out in our driverless AI recipes repository.
Great. Thank you, Jagdeesh. Next question, do you have any meetup community in Delhi? Yes, we do. But during the current times that we are in, everything is online. But if you are specific on finding it, it's Delhi Artificial Intelligence and Deep Learning. You'll find an H2O.ai logo on it. And I think with that, we are at the top of the hour and our questions. Do you have any concluding thoughts, Jagdeesh?
I think we're good. I think last thing could be to encourage people to visit our learning center. Like like a lot of our experts, grandmasters, and like professional trainers are training like in learning center and giving amazing content. Like people, they can check out our YouTube channel or our learning center for more things.
Great. Thank you so much for taking the time, Jagdeesh, and doing a wonderful presentation, answering so many wonderful questions. Thank you to our audience for coming in, asking all the questions, engaging with us. A copy of the recording and a slide deck will be sent out shortly after. Have a good rest of your day. Bye-bye.
Thank you very much, Saurabh.